So hello all, I hope you guys are all well and having a lovely week. So tonight, Middlesex University, product design engineering and design engineering, we're excited to host the 15th talk in the annual guest lecture series. So this series runs weekly throughout the academic year, Thursday evenings, bringing together a vibrant mix of speakers from across the full spectrum of design and engineering. So we have a mix of leading practitioners, opinion leaders, radical thinkers, and emerging talents to inspire and support your professional development. Tonight, we're delighted to host Michael Margolis. He's a maker in residence and a technical tutor at Middlesex London. Michael's bio and his CV is extremely rich and fascinating. He teaches a module on engineering innovation. He leads the software and hardware design for the Middlesex University motion platforms, the chairs that he might touch in his presentation as well, alongside the Myrtle robots using the computer science modules. So Michael's career commenced at Sony Corporation in various technical and product management roles, and this included the launch of the Walkman in the UK. He was also the new business manager responsible for product introductions, including stuff like the compact discs, the electronic cameras, and computers at Sony UK. Michael is the founder and a joint founder of multiple startups, including a technology consultancy, which in partnership with the international advertising agency TBWA, where he kind of provided strategic direction to clients like Microsoft, Sony, Lego, Philips, alongside obviously being the joint founder and technical director of a telecom startup, Global Communications Ltd, Limited, where he was responsible for designing and implementing communication products for clients such as IBM and Intel. His full bio was sent ahead of the talk with the email circulation. Michael's also the author of the Arduino cookbook, Make an Arduino Robot. He's the technical editor for Practical Electronics for Inventors, Programming Interactivity, and also a contributor to many open source projects, including the core Arduino distribution as well. So definitely feel free to read the bio in a bit more detail. And Michael will also obviously elaborate and kind of touch on his journey and projects and case studies he's worked on. Guys, as usual, and as Michael has mentioned prior to this, feel free to gather your thoughts, your questions, your comments in the chat throughout the talk. Put a little note in there if you want to kind of interact and interrupt as well in the positive light. And we'll have Q&A at the end, where if you guys want to, there's also an option to go live and interact with Michael after the main talk. So over to Michael now with the talk titled Innovation, Ideas, Implementation, and Insights. Michael, it's all yours.
Thank you, Ahmed. And good evening, good afternoon, everyone. Thank you for joining. I will be talking about what I learned about innovation throughout a very varied career. I worked, as you've heard, for a number of very different companies. I worked for huge international companies. I've worked for kind of small startups. I've been self-employed, whole range of companies. And in each of those experiences, learned considerable amount about product design, product development, and innovation. And what I'm going to be doing over this session is sharing with you some of those learnings. Some of what I learned was through talking to people who are more experienced and wiser than me, some through experimentation, some through learning from my mistakes. And I'm going to start off with perhaps the biggest regret in my experience, which was at university. And my mistake was misunderstanding the purpose of university. I thought I was told by my parents and the teachers before that the goal was to get good grades. And by getting good grades, that would get me a good career. But having had the career, what I realized was that what mattered was not the grades. They actually made very little difference to my ability to perform. What mattered was the capacity to adapt what I knew and acquire what I didn't know to address new challenges. Now, don't misunderstand me. I'm not saying you shouldn't get good grades. What I am saying is that it's not the grades themselves that, in my experience, mattered. It's what you learned, the skills that you acquired in doing that really mattered the most. The other mistake I made in university was the mistake of thinking that if lecturers were less ambitious about the assignment grading, it would be easier to be a better student. I've heard as a lecturer, well, why don't you say exactly what you want in order to get a great grade, and then I'll do it. Well, most things that are innovative mostly start off as ambiguous. Ambiguity is defined as something that's open to more than one interpretation or inexactness. And if someone follows existing conventional patterns, chances are actually quite low that one will hit on something new. And one's ability to find your way through ambiguity may indeed help your grades, but it certainly, in my experience, is likely to help your career. And this isn't just my view. There is a fair amount of research talking about the importance of ambiguity. And I'll just read you from one research paper from the National Science Foundation of the US, which I find quite informative. Engineers and designers are seen as problem solvers, yet the kind of problems students solve in classroom environments are different than what they will face in their professional careers. Research has demonstrated that to promote flexible thinking and to furnish students with the skills that will enhance their chance of being successful in their workplace, educational institutions should introduce students to complex, ill-structured, and open-ended problems. So I'll leave you with the thought that the next time you aren't entirely clear what it is that is being asked for, it's really your job to find out. My first job was with Sony Corporation. I started as an engineer. I started by adapting products that were originally developed for other markets, for the US or the Japanese market, for the UK market. But I soon got involved in working with the product designers to help them design the products to be more easily adaptable. And about halfway through my career with Sony, I had a very unusual experience. I had the marketing director of the company come into me and say, look, there's a product which is felt very important by the designers back in sorry, was there a comment?
No, I think there's someone just left the mic on, Michael.
Okay. I was told that there was a new product coming around, which was considered very important at head office, but the sales department saw the product and really didn't think it was going to sell. That product is the product you see in the center. It's something called Walkman. Many of you will be too young to know what that is, but it's the world's first personal audio. It's the world's first device that you could carry around and listen with headphones. And the problem was that when the salespeople, the people responsible for selling and marketing the product saw it, they looked at the price, which was £100. And £100 was a lot of money back then. This was the early 80s. It would be about, what, 600 and 700 pounds today. So a lot of money for what was essentially a tape recorder. It was a cassette recorder, which didn't record. And you could actually buy a cassette recorder, a dictation machine, which was the technology this was actually built on. You could buy a dictation machine for probably half the price. So this is a tape recorder that didn't record twice as much as one that did. It didn't even have a loudspeaker. And this is way back 40 years ago. The thought of people, particularly people who could afford 600 quid walking around with headphones, was absurd. At this point, nobody was doing it. So the general belief was, well, maybe we'll sell a few of these, but it's really not going to work. But the thing that convinced me when I was asked whether I would be interested in launching the product was putting on those headphones and becoming immersed in what the product was about, which was giving you an amazing sonic experience, which you can carry anywhere. I was pretty sure that this was something that was going to work. And that really started my movement from the engineering side to the kind of the product development side. And in that role, I looked at a number of products. But to give you an idea of the experience that I had with Walkman, what I realized, and this is true of many innovations, that customers may not be aware or able to articulate their needs when a new way of delivering those needs comes along. And what customers say they want is not necessarily what they need. Being asked to put a loudspeaker in the device actually would have undermined it. It would have degraded its core benefit, which was the amazing sound, but when listening through headphones. There's a saying that is supposedly by Henry Ford, and whether he actually said it or not, I don't know. But the saying, I think, is probably telling, which is, if Henry Ford canvassed people on whether or not he should build a motor car, they probably would tell him what they really wanted was a faster horse. When Henry Ford obviously started the Ford Motor Company, horses were the primary forms of transport. And a motor car was a pretty impractical thing, given that there weren't very many petrol stations or very good roads. And the core of innovation, I found, is looking at problems people actually have and coming up with new solutions that perhaps people couldn't articulate or even conceive of. And we'll look at some examples of that as we go along. Another experience I had in Sony, this was the time of something called Betamax. And again, many of you may be too young to know, but way back when, in the mid-'80s, there was the introduction of video recording, home video recording. And there were two competing formats. Sony introduced the world's first home video recorder. It was called Betamax. And another Japanese company, VHS, about a year later, introduced an alternative format. Sony were pretty confident that Betamax was going to win the market. They weren't too much worried about VHS because although Betamax was more expensive, it had much better quality. It was more reliable. It had a smaller tape, so it was more convenient. The products were better built. And Sony decided that given it was so profitable, they wouldn't license the product to any other manufacturer. Sony felt they didn't need to. VHS, on the other hand, licensed it to any company that was prepared to build it. And consequently, there were many companies that made video recorders and many, many companies that made the tapes. And in fact, not only made the tapes, but also pre-recorded tapes, videos, movies, which could be rented. And to cut a long story short, the wide availability of tapes, the wide availability of a range of pricing products meant that even though Betamax was a technically superior product, VHS was the winner. And the lesson I learned there is that successful innovation requires four things. There are three on here, which in the case of VHS, Sony did very well, which is finding the appropriate opportunity, which is inventing a home video recorder, identifying what to do is to make it in a way that it's reliable and of good quality, actually building it and delivering it to market. Sony did all of that, but it forgot the last thing, which they thought would be easy, which is capturing the benefits. And we'll be looking at some examples later on, but it's perhaps the least interesting aspect of innovation, but clearly the most important if one wants to be successful. Thinking about a great product, actually making it and delivering it is not the full story. Actually, one has to successfully deliver it to the market and make it successful. The marketing director at Sony was headhunted by an advertising agency, TBWA, which is now one of the largest advertising agencies in the world. And he was keen to, for his clients, use the expertise that I had in terms of understanding how technology could be applied to consumer products to those customers. And through the agency, I set up a technology consultancy company. And we had two kinds of clients. One was consumer companies that were looking to use technology, and in particular, the emerging computer technology. And the other was the technology companies, the people making the computers, the people who were making the software, companies like Microsoft, to understand what the opportunities were for building consumer products. Now, TBWA are the advertising agency for Apple. And although I didn't work on the Apple account, Apple are often cited as one of the premier examples of an innovative company. And in fact, at the time, my computer was an Apple II. That kind of shows how long ago it was. And the Apple II was kind of an amazing computer. It was really the most successful of the early home computers, but it was in many ways primitive. There was no graphical user interface, and you needed to be reasonably technical to do it. And what I'd like to share with you are kind of some of the experiences I had looking at how Apple evolved from that initial very successful product into new products. And the first one you may or may not recognize, that is from 1983. It's a computer called the Apple Lisa. This is a world-beating idea because it is the world's first home computer with a graphical user interface. Computers were becoming quite popular, but they were all inhibited by the fact that you needed to be reasonably technical to run the command line capability. So this was the first time that you could get a computer that you could open up a word processor and visually create your document and drag things around. There was no other way to do that. Surely it's a world beater. The problem was that the Lisa cost £10,000. The Apple II was about £1,500. £10,000 would be about £30,000 today. So it was very, very expensive, but worse than that, it wasn't reliable. That is, the technology wasn't really ready to support the processing power that this computer needed, and it overheated and wasn't reliable, and it almost bankrupted Apple. Apple learned from that mistake, and 1 year later, completely redesigned the product, made it much, much simpler, and came out with a product that I think many of you will recognize, which is the Apple Mac. The next product I want to look at is this. The Mac being successful, bringing a graphical user interface to anybody, Apple thought, surely we can grow the market hugely by enabling people to have this capability in a portable. There were laptop computers, but there were no laptop computers that had a graphical user interface. So in 1989, Apple developed the Mac Portable. Being the only GUI laptop, it had to be a success, surely. Well, the problem was, it was a portable, but it was a portable that weighed 8 kilograms. And it weighed 8 kilograms because the only way to get the battery life, the requirement set for it was, well, this thing needs to last for the duration of a transatlantic flight. So the only way that you get kind of 8-10 hours out of the thing was to put in lead acid batteries, which are incredibly heavy. And what was worse was that if you really wanted to see the screen when it was dimly lit, you had to use the backlight, which cut the power down to 5 hours, so you couldn't actually use it for the duration of the flight anyway. So it was a complete failure, and Apple barely sold any. But a few years later, it came out with the MacBook. Apple looked at what customers really wanted. They, for the first time, introduced the trackball in the location that trackballs are, which was kind of where the touchpad location. Addressed the technical issues, and the MacBook was the first of an incredibly successful line of Mac portables. And the last product I'd like to introduce is something called the Apple Newton. Now, this is an amazing innovation because it was the first time that you could take your computer power handheld and input using handwriting. So you had the world's first handheld computer with handwriting input. Got to be a world beater. Unfortunately, the handwriting recognition was so poor that it hardly worked. The screen was hard to read. The Newton was a complete failure. But a few years later, well, actually, it took Apple a number of years. Apple introduced the first of the incredibly successful range of iPads. And I show these because Apple is often used as an example of a highly innovative company, and indeed it is. It is one of the most innovative companies that I've come across. But despite their successes, it's very easy if you don't think through how users are going to actually interact and use the product, what its purpose is, what its not only what its capabilities are, but what its weaknesses are. It's unlikely you'll develop a successful product. So predicting whether a product to be successful is not so much about what the technology could be. It's more about all the factors that determine whether people will adopt it and how quickly they adopt it. It's pretty easy, in my experience, to develop a product which a few people who are interested in trying the bleeding edge product will buy. But buying something that is sustainable, buying something that the majority of the potential users will buy, takes considerable thought in terms of what those users actually need. And I'll throw in this quote, which I've always liked. It's from Alan Kay, who was the inventor of the graphical user interface, who said the best way to predict the future is to invent it. And for an innovator, that's not a bad idea. One of my clients, most of my clients were large companies, but one of my clients was really an individual that I'd worked with Sony, who had the idea that with the emerging computer power, but also emerging multimedia, that there was an opportunity to actually build a multimedia server to combine computer capabilities with email, video, voice, and data. And I was intrigued by the idea. Intel, or a company that Intel acquired, was just coming out with some processing cards that enabled one to do some of these things. And we worked together to create a communications platform, for which the biggest challenge was not so much the technology, but the biggest challenge was how do we ensure that, given that something like this had never been done before, how do we ensure that it will actually address real people's needs? And kind of here's a checklist, which I've used subsequently in many times subsequently. The first was to be absolutely clear on why we were doing this. What is its purpose? What is its value? Why would people actually want it? The second was, okay, what are the requirements in order to address those needs? And the requirements of what quality does it need to have? What resources do we need in order to make it happen? What resources need to be built into the product? When does it need to be done? All of those are conflicting, that modifying any one of those affects the others. So capturing those requirements was vital. It clearly needed to be done in a way such that there was a sustainable business. It needed to be funded. And the big challenge with the funding was that because we didn't quite know what the product needed to be, or more particularly, how exactly to address the needs of a market that didn't exist, we realized that we needed to iterate it. We needed to do prototypes, and we needed to test the prototypes. So we created a project plan that involved a number of iterations. We didn't know how many, where we would create a functional product. We would then test it on potential customers. We'd test it on potential users, and then monitor the product, monitor the progress of that, adjust the plan. And I think it was Proto 5, the fifth iteration, the fifth version of the working product, about 2 years after we started, that we actually were able to deliver the product. The customers for that were companies like IBM, Intel, Deutsche Telekom, and our largest customer was an organization called MDX Business Systems, which is a UK company selling communication systems, PBXs, switching systems, telephone systems, to small and medium businesses. Small and medium businesses are businesses anything from 1 or 2 users up to about 500 users. And they had the hardware and bought our application to enable the multimedia capabilities with their hardware, but realized that they really wanted to expand, they needed to integrate the application. So rather than externally attaching the application to the hardware, is to actually design hardware and software that work together, which is a major challenge. And to do it, I actually cashed out on my startup and became chief technical officer of this organization, and set about doing that. And the challenge here was that previously we were delivering what is primarily a software product, and it's relatively easy to enhance the software, add features, and so on. But when you're designing hardware and software together, the timescales go from weeks or months to years. So it required an incredible amount of planning and a level of quality assurance that we had never encountered before. The biggest challenge I had was, how do we find the skills to do all of the things that we needed to do? And here in particular, I was looking at what is needed in order for somebody to provide the quality assurance required. And one of the tests that was given is one that's caught my eye, and I'm going to give it to you. I'm going to ask you to read this sentence and tell me how many times the letter F appears. So read the sentence, tell me how many times you think the letter appears. And while you're doing that, I'll explain that there is no right answer to this, and I'll explain why the test is meaningful in a second. So I'm not going to be able to hear you, but I want you to virtually raise your hand if you said 2 or less. Raise your hand if you said 3, 4, 5, 6, 7. I'm not going to go on because there actually are 6 there. And the reason there's no correct answer here, and the reason why I show that, is that when I did this test myself, I think I got 3. I got 3 or 4, as did my engineers. The engineers, the core skill of the engineers was to focus on the core problem within the software when you're developing software or identifying kind of hardware solutions. There are too many variations to get lost in a sidetrack, and you need to very quickly focus in on what you think is important. But if you're doing quality assurance, you can't just focus in on one thing. You can't just focus in on the bit that we think is important. You have to look at everything. You have to look at the detail. And the quality assurance people were pretty good at finding all 6 of those Fs. And the engineers and designers were more than happy just to focus on what we thought was the core. The SDX Business Systems was, the product was successful and caught the eye of an organization called Bell Labs. Now, Bell Labs is the research and development arm of what was originally the Bell Telephone Company. And Bell Labs is one of the most successful innovation organizations in the world. And it was a remarkable experience working at Bell Labs. If you don't know them, as an example of if innovation is measured by the impact on society, this is a pretty good list. Bell Labs invented the transistor, they invented the solar cell, they invented the laser, they created the Unix operating system, the C and C++ programming language, they created the underlying cell phone technology, they created fiber optics and a bunch of other stuff. And it was really quite an experience working at Bell Labs. And one of the things that Bell Labs is famous for is by fostering innovation through collaboration and diversity. They actually structured the way the offices were laid out. The offices in the US were in a huge 2 million square foot building, which had 6,000 researchers and engineers. And rather than being put into cubby holes, they organized the building such that the offices themselves were always shared by 2 people, and the offices were absolutely tiny. It was basically just a desk for each of the 2 people, but with huge amounts of common space. So nobody had a window office. In order to see a window, you had to walk. All the corridors were actually on the outside. And to get to the loo, you had to walk all the way down the corridor. And the corridors were so right at the end of the building. So you had to pass everybody else's office to do it. And consequently, you couldn't help but run into people with skills that often were helpful in addressing this. I mean, for example, the transistor couldn't have been done if it didn't have skills that involved the physics of semiconductor technology, but it also needed electrical engineering. It needed somebody model making to actually construct that device you see on the upper left is actually the world's first transistor to actually construct that. And what I found there, and I found it subsequently, is that diversity, different aspects, different points of view, different skills is a key component of innovation. So Bell was successful because of all of these things. Basically, innovation wasn't a tick list. It was the way they actually ran their business. But they weren't just focused on the technology. They were aware of their customers. I mean, initially the telephone company and then third parties. They were highly collaborative. They encouraged trying things quickly, rapid prototyping. They were very supportive of things that didn't work, encouraged risk-taking and managed those risks successfully. And their processes and metrics were not about how hard you worked, but about what you achieved. One of the frustrations, I think, that sometimes some of the students I talk to are discouraged because however hard they worked, sometimes it's felt that the hard work didn't result in a good grade. Well, one of the things that I found in innovation is that you're not paid for hard work. You're paid for the results that you get. One of the things that I wanted to point out, how are we doing? We're doing fine time-wise. One of the things that I wanted to point out was that Bell Labs had been hugely successful through most of the 20th century. But the last role that I had with them was helping to develop internet technology for communication, taking the experience that I had developing multimedia systems and looking at how that could be applied to the phone system. Now, the traditional phone system that had been built up since the time of Alexander Graham Bell was called circuit switched, where there was actually a physical wired connection between the endpoints of the telephone, and the telephone exchanges were about connecting those. And the benefit of those was that the voice quality was always controlled. You knew exactly what the level of quality was, and it was very reliable compared to the alternative, which was being evolved, which was using the internet, which is called packet switched, where you are sending packets of media, voice over IP or video, over the internet. And as all of us know now, and this is probably 15, 20 years later, it's still not 100% reliable. And the problem that Bell had was that they really were uncomfortable moving from a very well-known, very reliable technology, which is circuit switched, into something that clearly wasn't as good in the sense of not as reliable. And the voice quality, as all of us have seen on calls, the voice quality can be very variable. And consequently, drag their legs in terms of introducing it. and I think has probably suffered in the consequence. And that aspect of a company being hugely innovative, very, very successful, then being undermined by a less successful technology is something that's seen time and time again, not just by me, but it's been well studied. In fact, the most famous study is by somebody called Clayton Christensen, who in a book called The Innovator's Dilemma gave many examples of this. And I'll just very quickly take you through it. Basically, this chart shows that products improve performance over time. And typically an innovation, when it is first introduced to the market, underperforms. But sustaining innovations, improvements, bring it up to the level that customers are comfortable with. And then what companies do is they add features and capabilities and they keep improving it and they keep improving it. Disruptive innovation, disruptors come in and introduce a product which initially is inferior in some ways, but offers sufficient benefit to the customer. And sometimes that benefit is lower price, or sometimes it's added capability, sometimes it's both. And and consequently, in more times than not, Christensen found, and I've seen it as well, more times than not, the disruptor wins. And there are many, many examples of disruptive innovation. The whole computer industry is one example after the other of companies like IBM then being kind of out innovated by smaller companies. In fact, many of the examples that I would give in my lecture are companies that don't exist anymore because they just keep getting out innovated. There are examples not in the technology industry. Amazon is a good example of disrupting retail by coming in and offering a completely different business model. The experience isn't as good as being in a bookstore, being able to browse, being able to buy a coffee, but the benefits of lower price and convenience outweighed it. So around this time, being a little bit frustrated by the big company politics at Bell Labs, and given that they wanted to move the my division, because it was based on the old SDX group in the UK, they wanted to move that into the US because my family live here and I've lived here for my entire working life. Decided that I would cash out and semi-retire. And given that I was at this time doing a lot on microcontrollers, there was a new technology called Arduino that was available, and I was doing a fair amount online, initially in forums, reading and learning about the technology and then helping people with the technology. I got approached by a publishing company, O'Reilly Media, who wanted to do a book on programming interactivity and wanted somebody who could just check that the content was correct. So I took a part-time work doing technical editing on that book, and then that led to other publishers. One of the books that I did more recently was a book called Practical Electronics for Inventors as technical editor. And then I was asked, well, there isn't really a book that covers the basics of how to do lots of different things with Arduino. And I was asked whether I'd be interested in writing that book. And I'd never really done writing before. I mean, I'd done things like white papers, but there you write a kind of a half dozen pages on the technology, then give it to the marketing department, who then water over the technology and kind of wordsmith it in marketing speak. But I'd never really done a book before. But I was encouraged to do so. I was offered two editors, one that had some experience with the technology and another that could help with some of the writing stuff. And I decided to take it on. And it was quite an interesting experience because one of the editors, the editor that, well, it doesn't matter, the editor that I work most closely with, every chapter that I wrote would come back with just about every sentence with a criticism. Can you shorten this sentence? Can you clarify this? Can you remove the jargon from that? And I was constantly being bombarded with constructive criticism. And given I'd never done it before, I thought, well, maybe this isn't for me. But luckily, and I guess they figured this out, the other editor would read exactly the same stuff and say, oh, great, Michael, I didn't realize you could do that before. I had not seen anybody who'd done that. I now see how you can benefit from it. And that combination of constructive criticism and reassurance was what enabled me to kind of stretch myself and get into something new. And I mention it because I realized that students often get the constructive criticism. They don't often get the reinforcing side, but it's the constructive criticism that's really valuable. It was the constructive criticism. I mean, the reinforcement certainly made me feel good, but it was the constructive criticism that turned the book into something that was shortlisted as the best, one of the best technical books of the year it was introduced. And it's been incredibly successful. And I don't know whether Nick Weldon is listening on this call, but if he is, shout out to him, because he really helped me finish it. I was about 90% of the way through it, and it's just really hard work. And he kind of helped me finish it off. He also introduced me to Middlesex University. He invited me to one of these lectures, a guest lecture 10 years ago. And I gave the guest lecture and was then told, and I talked about some of the robots that I'd built. And I was told, well, Middlesex is building a robot. You may recognize some of the people in this picture. I don't know whether you know Franco's head of computer science. You certainly know Pooja. You may know the person on the left-hand side who was the referee for this robot football contest that that we had. Middlesex needed to build a robot. Pooja kind of led a team to develop a robot that could be used in computer science. The robot was called Myrtle, I think, because Myrtle was the name of one of Franco's favorite drinks. But anyway, the robot on the left was the original robot that that we built. And it then evolved to had custom circuit boards and some more sensor capability, but still based on the same kind of core platform. Unfortunately, and this sometimes happens, the motors that we used were very innovative. They were a combination of motor and wheel integrated in one, and that had huge advantages, but had at this point the major disadvantage that there was only one manufacturer of them, and they stopped making them. So we had a robot with no motors and wheels. So we had to kind of redesign the motor, the robot to handle a kind of more conventional motor, which you can see on the right-hand side. We kind of over-engineered this one a bit with metal, thinking, well, if it's going to be dropped, it needs to survive. And we realized that it really didn't matter. And the final version of the robot is the one you see on the bottom that's still being used. You may have seen that. We use it in outreach. It's a robot that we were able to simplify it by 3D printing the kind of core components instead of using metal. And by using the latest computer technology, we were able to reduce the computer cost. The computing power on the robot in that picture is about 60 pounds for the combination of the Raspberry Pi and the rest of the computer stuff that's sitting above it. It's now down to 6.50 pounds using a Pico. Another thing that I work on in Middlesex are the motion platforms. The one on the left is the very first one. That was in existence. I didn't design that one, but there was no software for it. So I was asked to design some software. And the latest kind of, or a later iteration of that. If you haven't seen the platform, here's a quick video. Are we doing okay on time? I've got maybe 10 minutes left. If you haven't seen it, this is the motion platform. Anyway, we have a STEM event, I think, coming up. If you haven't experienced it, it's a lot of fun. What you see in this picture is the next evolution of it that we are working on now. It's designed to have a flat platform as opposed to a chair, which is the one you saw, which makes it much more flexible in terms of what we can put on it. And one of the reasons for doing it, this is the that's what the platform looks like with the top off. This is showing the motion of the platform. One of the reasons for doing it is that the very first motion platform we did was used by the Royal Aeronautics Society in an outreach program, where they did a schools program to encourage schools to develop a flight simulator. And in fact, the winning group actually built a copy of our motion platform. The Royal Aeronautics Society is running a new program starting now to design a flight simulator. But this one, and I'll read the requirement. Can you use your innovation and creative skills to design a flight simulator that will enable able-bodied and disabled people to experience the thrill of flying? And, excuse me, the new platform is designed so that it can actually take a wheelchair, as well as all the flight simulation stuff. So that's something that's going to be happening over the next year. And if you're interested in motion platforms and or flight simulators, please contact me after this call. So I'm now teaching engineering innovation, and one of the things we cover is product development. And I wonder how many of these you think are good ideas to follow. The more features we can put in, the more customers will like it. Is that a good idea? Well, my experience with Walkman showed that putting in features that are not essential to it, the core value of the product, actually undermine the product. The sooner the project is started, the sooner it will be finished. Seems to make sense. But starting a project before you have thought through all of the aspects of it and ensuring exactly what its requirements are, well, not exactly, but being clear at least on what its requirements are, what resources you need, and so on. Starting a project before you are clear on those, it's likely to actually take longer. Certainly that's been my experience in industry. Our development plan is great. We just need to stick to it. Well, that would be great if nothing changed. And it's certainly a problem in innovation, because in any significant development, typically the environment is so changed by the time you finish. The technology that you're using, the marketplace requirements, the competitive environment, the market plan has to adapt if it's going to be successful. And then the last is, we'll be more successful if we get it right first time. Well, the more innovative something is, the more ambiguous it is, the less you know about it, the less likely you are going to get it right first time. Be prepared to iterate. So just a few comments on, or suggestions on, planning and implementing projects. The first is think before you build. You'll save time by pre-planning. Avoid just-in-case features. It's very tempting to say, well, while I'm working on this bit, I can add this and or improve that capability. If it's not required, if it's not essential, but doesn't add value to the final product, if you're not sure why you're doing it, don't do it. Because probably by the time you do know what that feature needs, it's going to have to be something different anyway. Don't reinvent the wheel. Try to reuse as much as possible that's not core to whatever it is you're innovating or building. Don't waste time just building something that somebody else has done. Focus on the stuff that's actually new or specific to what you want. And some advice on making it. Test often. Some people think that testing wastes time. It doesn't. It saves time. Simplify. Try to keep things as simple as possible. Making something simpler usually means that you're going to spend less time fixing something. If you're struggling with something, you may want to think about starting over. just because you've gone down a route, you've invested time, stand back and look at it and think, well, if I actually started this over, used what I learned to think about a new approach, would I actually save more time? And a corollary of that is start with the most difficult thing first. Start with the bit that you're least sure of, the thing that's most likely to cause a problem, because you have less invested in the other stuff if you do need to start over. Something I see students doing quite often, don't confuse activity for progress. The fact that you're working hard doesn't mean you're actually getting close to reaching your goal. Make sure that what you're doing is actually moving yourself forward. Just because you're busy doesn't mean that you're making progress. Be prepared to experiment, to try different things. Have fun doing it. You're more likely to do something innovative if it is fulfilling. But perhaps most important is be tenacious. This stuff isn't easy. So work hard, overcome the problems. A book I recommend if you want some great examples of innovation is a book by Walter Isaacson, one of my favorite authors. It's called The Innovators. It has lots of examples of innovation, particularly within the technology industry. And here's some quotes. I think that the word innovation has become a buzzword. It's been drained of much of its meaning because we overuse it. Innovation comes from collaboration. It comes from teamwork. It comes from being able to take visionary ideas and actually execute them with good engineering. There actually are, I think, 4 copies of this in the library if you want to get it out. So my final advice is be clear on your goals when you're doing a project, identify why and how your project will have impact, and understand the difference between striving for perfection and striving for excellence. A great product delights users, but no product is perfect. Okay, do we have any questions?
Amazing. Michael, that was a really interesting overview of innovation. Like, what is an innovation? Different companies and technological innovations going from ideas to implementation, the challenges, learnings, and failures, and superb case studies and examples throughout as well. Thanks a lot for the talk. It was brilliant. Questions coming in, guys. Feel free to continue to gather your thoughts and questions and comments in the chat. If you want to go live and interact and ask your question live to Michael, feel free to put a request through in the chat as well. First question coming through from Tony Smith. Michael, what would you say is the key difference between perfection and excellence?
The difference is to focus on what really matters and get that right. The problem with many of the 4 examples I gave, the 3 examples I gave of Apple, and it's Steve Jobs had many strengths, but this was perhaps his kind of one weakness, is trying to make the technology make the technology as good as possible, ignoring the fact that as good as possible may not actually add any user value. So excellence is delighting the person who's going to be using what you're making. Excellence is doing engineering for, perfection is doing engineering for its own sake.
Amazing. I guess this is more of a comment rather than a question. So Luke says, thank you for your advices. And Luke and Javier, I'm not too sure which of the two, but they say one of the best talks this year has been extremely helpful for their final major project as well. So that's more of a comment and a thanks to yourself, Michael. Another question coming in from Irene. What's the best way to research similar projects and similar concepts?
The best way to research projects that are similar to ones that you want to do? Is that the question?
Yes.
Okay. What I tend to do is, if I'm starting on a project that is new, I will look to see what's been done that's similar. And depending on the nature of the project, depends on how you look. If it's a technology project, I will look at things like on forums. I'll try to get an idea of what commercial projects exist. And to simplify it, It helps if you think about what is the aspect of the project that you find most interesting. Excuse me, are you solving a particular problem? Are you doing something that is primarily aesthetic? Are you doing something that's practical? And by focusing on the nature of what you think is the most important aspect of the problem might help you narrow down the search. I think the key to it is that when you're searching, always bearing in mind what you think the core benefit of the outcome of the project would be.
Amazing. Another question for yourself, Michael, is how would you define innovation?
It's been defined in a number of ways. The short answer is innovation is a good idea applied. Great innovation is a great idea applied. The difference between invention and innovation is coming up with something new. Innovation typically is coming up with something new, but the difference between invention is it's the application, it's applied. I measure innovation by its impact. An invention may be granted a patent, but if it doesn't improve something, if it doesn't make any difference, then by my definition, it's not an innovation. So innovation is applying an idea, and the measure of innovation is by the amount of impact that that has.
Amazing. And I think that leads on quite nicely to the next question. So some of the students I mentioned in light of their final major project, for example, if they were working on an innovation kind of a concept or a project, what would be the dimensions of innovation and how could they position their particular idea?
How do we position it such that we maximize innovation? I'm not sure.
Yeah, so for example, if you had the different dimensions of innovation, it would allow them to position their idea in relation to existing technologies or activities or products that exist, and so forth.
A dimension that I tend not to use is the technology. That is, when I am evaluating innovation, it's not so much what it's made of, or even so much how it's made, although sometimes that does matter, but why it's made, why it matters, how that thing is going to do something by some metric better, and what that metric is, you can define yourself. I mean, it may just be something that does something that looks better, and that is still an innovation. But focus on the impact, focus on what your project is going to do something better than alternative ways of doing it. And better may be less expensive, better may be using materials that are more eco-friendly, but by some measure, you're looking at some kind of improvement or benefit that's coming out of that project.
Amazing. And I guess the final question for yourself, Michael, is, the bio that was circulated was fascinating in terms of the range of projects and companies that you've worked in. What's your experience like in terms of creating a startup and working as a founder or a co-founder in a startup?
Creating a startup is really hard. One of the things that you don't have is time on your own. It's a huge drain on your time. It's a huge drain on your energy. But it's tremendously rewarding in the sense that you are constantly doing something new. The range of experience I've had is that there's kind of a balance, a trade-off, if you will, between comfort of working for a big company, but the difficulty in actually making a difference. And whereas with the startup, you feel that you can make the best of yourself, but you really do need to be tenacious to do it. And my recommendation, I am very glad that I didn't do my startup until after I had had some experience with a large company. And the reason for that, well, it doesn't need to be a large company, but I had some practical experience. The reason for that is that I had an opportunity to try things. I had an opportunity to leverage the experience of people that had been through it before. And so when I got to the point of doing the startup, there was a huge amount that was new and unknown. It was ambiguous to the extreme. But I'd had some things, tools to deal with that. And one of the things that kind of harking back to the beginning of this presentation is that I didn't realize that when I was doing my university stuff, I thought I was just getting, acquiring facts and getting grades. What I didn't do, and what I would encourage all of you to do, is to leverage the experienced people that are lecturers, people you're working with. Ask them these questions and benefit from their experience.
Amazing. Another question coming in from Irene. What can you tell us about innovation roles in large companies and corporations?
Large companies find innovation much, much harder, and particularly large companies that have an existing revenue stream. Bell Labs was an example of an organization that just found it really difficult to do something. I encourage you to read The Innovator's Dilemma, the Clayton Christensen book, which is really about many case studies of large industries being out innovated. But there are many smart companies. I mean, Intel is one that realize it's happening and are able to do something about it. There are a lot of companies that realize it's happening and just don't have the wherewithal to do it. There are companies, Intel is well, there are many, but I'll just use Intel as an example, that realize that it happens, and create an environment which does sustain innovation. So I certainly wouldn't say don't work for a large organization, and working for a large organization can be a good way to develop skill. But if you're looking for an innovative organization, look to see how supportive they are. An extreme example of a supportive innovation is Google, who actually encourage people to create internal startups, to create projects within the organization. Some of them are funded, and if they're successful, they proceed. But Google actually will reward a person who does a startup who, having done a reasonable analysis of it, comes to a conclusion that it doesn't make sense to proceed. They actually not only don't punish people who take a gamble and don't work, they provide a safety net for it. And if you're looking for an innovative company, look to see companies that are supportive of not only giving you the tools to innovate, but the support to take chances.
Amazing. And Irene's thanks you for both the answer and also the reference to the book. And another question coming in, Michael. You mentioned a couple of times about cashing in at the end of a startup. What's the process like in terms of cashing in a startup and moving on? And how young did you retire?
It's different. It's different for different organizations. So in my case, I cashed out twice. The first was Global Communications, and the Global Communications situation was unusual because the Global Communications wanted to continue. They had many, many customers. I was enticed by one particular customer. So I left the organization, but the organization still exists. And basically it's about whatever value if you have shares in the company, it's the value of those shares. The second time I cashed out was in the Bell Labs, where again I had shares in the company, a much smaller share percentage of Bell Labs, I have to say. where I cashed that again. And that being a very large organization, it's a very structured and very simple process, as opposed to the negotiation with a business partner about, well, how much is this really worth? In the case of Bell Labs, being a public company, the shares have value, and there's a very simple process. So the short answer is it really depends on the nature of the organization. If you're going to join a small startup and you're going to have a partner, my advice is to find a partner you trust, such that when you do get to the point of cashing out, it's as painless as possible.
Amazing. And another question, what is your experience in terms of intellectual property protection within the university context? And do you have any experience in setting up a spin-up or a spin-out company within the university?
Right. Oh, I didn't answer the last part of the question. I was 60.
Awesome.
Intellectual property is a key component of innovation, and I came across it in many cases. The most significant one probably was the SDX Bell Labs, because Bell Labs have a huge business in intellectual property. I mean, they have a ton of inventions. When you invent the transistor and all the follow-up to the transistor, you have a dozen Nobel Prizes. You've got a lot of intellectual property there, and they've got a lot of lawyers. And I kind of skirted over the acquisition. When Bell Labs came to us, they had a stick and a carrot. They were very complimentary about our technology when they wanted to buy us, and offered quite a reasonable price. That was the carrot. The stick was, oh, and by the way, we have a patent which we think you're infringing. And should you not agree to this selling price, we will sue you. And we have plenty of money and legal resources to do it. Now, we looked at the patent and we didn't think that they would succeed, and were able to negotiate an improvement to the carrot that we were all happy with. But clearly, the lack of protection that we had with intellectual property, the lack of attention to it, did put us on the back foot. So being aware of intellectual property is important. But it came up in a number of cases. An experience I had as a consultant, I didn't mention Lego, but Lego were one of the clients of my consultancy. And I did a presentation to Lego in Billund, which is their head office, on how they could use computer power to enhance their product. In that presentation, I did a simulation of a computer manual where you actually 3D built the Lego bricks. And my presentation went from smiles on their faces and keen interest to, at one point, one person who kind of got up with a big frown on his face and said, Michael, could you please leave the room for a moment? And basically came back and said, could you please sign this non-disclosure agreement to say that should Lego ever come out with a product like this, that you will not sue Lego. And it was the first time that I'd ever actually faced a non-disclosure agreement. Luckily, it wasn't a problem, and I was never quite sure whether I gave the idea to Lego. I suspect that it was one that they already had in place. But being aware of non-disclosure agreements and what they are and why they're valuable is something that's valuable. So, in summary, understanding intellectual property is very important if you're going to be doing something with innovation.
Amazing. I think that concludes the Q&A, Michael. So at this juncture, it's been a great opportunity for us. Obviously, thank you for taking out your time and joining us tonight. Both the talk and the Q&A was really interesting and inspiring. And from all of us at Middlesex University, design engineering, product design engineering, we thank you, Michael, for your time and for the talk.
My pleasure.
Amazing. And for all of us students, alumni, participants, Michael's details were sent to your emails ahead of the talk as well. So definitely feel free to browse, read a bit more as well in terms of the bio and connect with Michael as he offered within the main talk as well. And to conclude, keep an eye out on your emails for the details of next week's speaker and the links to the talk next week as well. So until then, stay well, stay safe, and thank you guys.